Simultaneous equations. So far, we have solved simple equations with only one unknown. Simultaneous equations are equations that have the same solution. All the equations are satisfied by the same values of the unknowns. In this video, we will determine the solution to two equations with the same two unknowns. The two equations are used to produce a new equation containing one unknown only. We will look at two ways of doing this. In this video, we will introduce the method of elimination. In the next video, we will introduce the method of substitution. Examples of simultaneous equations are 2x plus 3y is equal to 1 and 5x plus 4y is equal to 6. A second pair of simultaneous equations might be x plus y is equal to 12 and x minus y is equal to 2. And a third example, 3x plus y is equal to 18, 2x minus y is equal to 7. In elimination, we are going to eliminate one of the unknowns. How? We know that if we subtract a quantity from itself, we are left with 0. For example, 5 subtract 5 is equal to 0. Negative 6 subtract negative 6 is equal to 0. Of course, this is the same as negative 6 added to positive 6, so that's 0. 3x subtract 3x is equal to 0. And negative 4y subtract negative 4y is also equal to 0. Thus, we see that if both equations have the same coefficient of one of the unknowns, we can subtract one equation from the other to eliminate that unknown. And if we add quantities of the same magnitude but with different signs, we also get 0. For example, 8 added to negative 8 gives 0. Negative 9 added to 9 gives 0. Negative x added to x gives 0. And 7y added to negative 7y also gives 0. Here we see that if the magnitude of the coefficient is the same, but they have different signs in the two equations, we can add the two equations together to eliminate that unknown. Let us look at how this is done using an example. 2x plus y is equal to 7, we call that equation 1, and y minus 2y is equal to 1, we refer to this as equation 2. The magnitude of the coefficient of x is not the same, neither is the magnitude of the coefficient of y. We can multiply equation 2 by 2 to make the magnitude of x the same. Multiplying both sides by 2, we get 2 multiplied by x minus 2y is 2x minus 4y is equal to 2. Writing over equation 1, so equation 1 and equation 3 is next to each other, so the subtraction is clearer. And now we subtract equation 1 from equation 3. 2x subtract 2x is equal to 0. Negative 4y subtract y is equal to negative 5y. And 2 subtract 7 is equal to negative 5. Negative 5y is equal to negative 5 is a simple equation, and we know how to solve it. Dividing both sides by negative 5. Negative 5 cancel to leave y on the left hand side, and negative 5 into negative 5 is equal to 1. Y is equal to 1. Once we solve one unknown, we can substitute the solution into any one of the equations to determine the value of the other. Substituting in equation 1 gives 2x plus 1 is equal to 7. Solving for x, subtracting 1 from both sides, gives 2x is equal to 6. Dividing both sides by 2. 2's cancel. 6 divided by 2 is equal to 3. X is equal to 3. The solution to this pair of simultaneous equations is x is equal to 3 and y is equal to 1. In this example, it was fairly easy to recognize that the second equation should be multiplied by 2. But what about this equation? 2x plus 3y is equal to 1 and 5x plus 4y is equal to 6. How do we make the coefficients the same? We use the LCM. The LCM of 2 and 5, the coefficient of x, is 10. So we can multiply in a way to get the coefficient of each equation to 10. Thus, we can multiply equation 1 by 5 to get 10x plus 15y is equal to 5. And we can multiply equation 2 by 2 to get 10x plus 8y is equal to 12. Now we can subtract equation 4 from equation 3 to eliminate x. Conversely, The LCM of 3 and 4 is 12, the coefficients of y. So, we could multiply equation 1 by 4 to get 8x plus 12y is equal to 4, and we can multiply equation 2 by 3 to get 15x plus 12y is equal to 18, and we can subtract equation 4 from equation 3 to eliminate y. What about 5x plus 6y is equal to 37 and 2x minus 3y is equal to 4? We would recognize the LCM of 5 and 2 is 10, but the LCM of 6 and 3 is 6. So we just have to multiply the second equation by 2. Multiplying would give us 4x minus 6y is equal to 8. We rewrite the first equation, and then we can easily just add equation 3 to equation 1 to eliminate y. Thus, it makes sense to take a second to evaluate both x and y to determine which one is easier to eliminate. So in summary, we eliminate one unknown by either making both coefficients the same and subtracting one from the other, or making the coefficients the same magnitude but of opposite signs and adding them. We then solve the resulting simple equation to determine one unknown, and then we substitute this result in any one of the equations to determine the second unknown. I will now walk through 3 examples completely. Example 1. 3x subtract 2y is equal to 19, we call it equation 1, and 2x plus 3y is equal to 4, equation 2. The LCM of 3 and 2 is 6, so we are going to multiply equation 1 by 2 and equation 2 by 3 to eliminate x. Equation 1 by 2 gives 6x minus 4y is equal to 38, and equation 2 by 3 gives 6x plus 9y is equal to 12. Now we're going to subtract equation 4 from equation 3. This gives 6x minus 6x is equal to 0x, the x is eliminated. Negative 4y subtract 9y is equal to negative 13y, and 38 subtract 12 is equal to 26. We have a simple equation which we can solve for y. Dividing both sides by negative 13, the negative 13 on the left hand side cancels to leave y, and 26 divided by negative 13 is equal to negative 2. Thus, y is equal to negative 2. Now we're going to substitute y is equal to negative 2 in any one of the equations. Substituting y is equal to negative 2 in equation 1, we get 3x minus 2 multiplied by negative 2 is equal to 19. That is, 3x plus 4 is equal to 19. We're going to solve for x. We're going to subtract 4 on both sides to get 3x is equal to 15. Dividing by 3 on both sides. The 3's cancel. 15 divided by 3 is equal to 5. Thus, x is equal to 5. The solution to this simultaneous equation is x is equal to 5, y is equal to negative 2. Example 2. We have 3x plus y is equal to 2, and 4x plus 3y is equal to 3. The LCM of 3 and 4 is 12, but the LCM of 1 and 3, the y coefficient, is 3. So we simply have to multiply the first equation by 3 to eliminate y. Multiplying equation 1 by 3 gives 9x plus 3y is equal to 6. Subtracting equation 3 from equation 2 gives negative 5x is equal to negative 3. Solving for x, dividing both sides by negative 5. Negative 5's cancel. Negative 3 divided by negative 5. 3 divided by 5 is 3 over 5. And a negative divided by a negative is a positive. X is equal to 3 over 5. Substituting x is equal to 3 over 5 in any one of the equations. Substituting in equation 1, we get 3 multiplied by 3 over 5 plus y is equal to 2. That simplifies to 9 over 5 plus y is equal to 2. We want to solve for y. We're going to subtract 9 over 5 on both sides to remain with y is equal to 1/5. Thus, the solution to this pair of simultaneous equation is x is equal to 3/5 and y is equal to 1/5. A third and final example. 5x plus 6y is equal to 37. 2x minus 3y is equal to 4. The LCM of 5 and 2 is 10, but the LCM of 6 and 3 is 6. So we can multiply equation 2 by 2 to eliminate y. Equation 2 by 2 gives 4x minus 6y is equal to 8. We write in equation 1, so they are one on top of the other, so it's easier to see the addition. Then we add equation 3 to equation 1 to eliminate y. 4x plus 5x is equal to 9x. Negative 6y added to positive 6y is equal to 0y. And 8 plus 37 is equal to 45. We can solve this simple equation for x. Dividing both sides by 9, the 9's cancel to remain with x, and 45 divided by 9 is equal to 5. X is equal to 5. We can substitute x is equal to 5 in any equation to solve for y. Equation 2 seems to be a simpler equation than equation 1, so we'll use equation 2 in this example. Substituting x is equal to 5 in equation 2. We get 2 multiplied by 5 minus 3y is equal to 4, which gives 10 minus 3y is equal to 4. Solving for y, we're going to minus 10 on both sides. To get negative 3y is equal to negative 6. Dividing both sides by negative 3. Negative 3's cancel to leave with y. And negative 6 divided by negative 3 is equal to positive 2. Y is equal to 2. So the solution to this pair of simultaneous equation is x is equal to 5 and y is equal to 2. That is it for this video. I am Mr. Dube. If you found this video helpful, if you appreciate what I'm trying to do on this channel, please like this video. If you are new to this channel, please subscribe. Join me in the next video.